Hey guys, we're at packet 2 for Algebra 1, Scatterplots and Measurements. Okay, so we worked through these problems, right, in class, and these, and not those, but then these. Okay, so we only have this one page to do, so let's do it. All right, so it says our topic today is numbers and quantities. Okay. So when I look around the page, I see here that, I've got 2 learning goals that fit on a page. Okay, so I'm going to start here, and I think we've already kind of started this basic idea. The question asks, a ruler can measure a length to the nearest 0.1 centimeters. Okay, so my measurement, if I could measure the length of my pencil, maybe it would be 4.8 centimeters. That's the nearest 0.1 centimeters, okay? Which of these lengths is the most precise measurement that the ruler could make if a wire really was 13.58 long? Okay, so when we look at this, it's going to be like 13.5 on my ruler. So this is my ruler right here. And this length is going to be somewhere between 13.5 and 13.6, okay? So I should round up, and that's as accurate as I can get, okay? This is not to the nearest 0.1 centimeters. This is not to the nearest 0.1 centimeters. But I should be able to get to the nearest here. Make sense? Okay. Sam wishes to construct a model that predicts the amount of damage caused by a thunderstorm. Describe 2 independent variables that could be included in his model. So the amount of damage caused by a thunderstorm. Also describe how to measure each variable and the units of the measure. Do not write a formula. Okay. So just like we have hurricane damage, the amount of damage could be measured in money, right? And this could be measured in number of homes, right? So if we surveyed after a big hurricane, how many homes were damaged in the city of St. Pete? We could ask the insurance companies how many homes were damaged, and then we could say total cost of damage. Okay, you can't get a question like this on the EOC. There could be an infinite number of answers here, but it makes sense that based on what they described, that the more homes that are damaged, there would be an increase in the cost. So units is in money and units is in number of homes. Okay. How would I measure it? I would measure money in dollars. I don't want to measure in rubles or euros, right? How would I measure number of homes? Counting, right? In even homes. So I probably would just say, if half your home is damaged, I'm not going to take a decimal. I'm just going to count that. If you had any amount of damage, you would count as one home. Even number of homes. Okay. Variable 2. Oops. Okay, sorry. I should have done this. So variable 1, we could say is number of homes, right? That's what I put here. And variable 2 is money in dollars. How would I measure this first one? Counting in even number of homes. That's each exact number of homes, right? Here, how would I measure? I would count in dollars. All right. What's my description? Total cost damage, right? What's my description here? Number of homes. We had to use some creativity here, right? So anything creative like this would be hard for them to ask. So it's more about our discussion than actually asking a question. Okay, so we took 2 questions from this side. Let's go ahead and take a question from this side, right? Let's try to do a couple on this side. I'm going to look at this bottom one, 5. Maria was asked to show on a graph how the number of visitors to the aquarium, we have an aquarium, right? The Florida Aquarium in Tampa. How did it change over the years? So we look at the aquarium and how it changed. Looks like a lot more animals live there over the years. So here it went down slightly, it went up, it went up, it went really far down. It went up, 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 it went down slightly and down slightly. So, but in general, it looks like it went up. So here it says, choose a scale and graph it. This is something you notice that I do all the time. So they want you to specifically think about thinking out loud about the years. Okay, so I want to go from 44 to 2000. So I don't know. Okay, so we'll call this the 40s, the 50s, the 60s, the 70s, the 80s, the 90s. And that would be the 2000s, right? I just kind of spread it out evenly, right? So this is the x-axis, and this is the year. All right, now let's look at this vertical axis. How much did the vertical number change? The population went all the way down. There's my lowest number. And all the way up to my highest number. Okay, so 100, 100, 200, 300. Okay? What is this? This is my population in thousands. Right? So 100 doesn't mean 100. It means 100,000. Okay, now I can graph it. Clearly explain why you chose the scale you used. I used the scale on the X from 1940 to 2000 because that's my max and my min, right? I use the scale 0 to 300 because, 0 to 300,000 because that's my max and min. And I used this 100, 200, 300 because all my Y values were in thousands. So I was too lazy to write 100,000, 200,000, 300,000. It was easier to just write 100 and say that those are in thousands. Okay, now we're going to graph. So 44, 288. So 44, 288, somewhere right there, right? 49, 270, 49, 270. That's almost 352, almost 300. So what's happening here? It's like, wait, I'm going to go up to 350 and I'm going to fall off the page. So you're like, oh, now I know why this takes a little bit of planning. Okay, so maybe I should space this slightly different to give myself a little bit more room. So I'm going to go up by every 3 instead of every 4 to give myself a little bit more room. Okay, so 1, 2, 3, I'll call that 100. 1, 2, 3, I'll call that 200. 1, 2, 3, I'll call that 300. 1, 2, 3, I'll call that 400. Okay, this is, again, the point of the task. I'm literally being asked to think about why I made the choice of gapping this, okay? Now I'm going to graph. Okay, so 44, 288, 49, 270, 52, almost 300, 58, pretty much 300, 61 is 87, so you see how we know that's a big drop. 65, back up to 261, 271 at 280, 978, 308, 85, 311, 90, 360, 97, 340, 2000, 340. Okay, so besides this weird year, basically it went up over time, and that's what we talked about this year and scatterplots. So what does this learning goal do? It's really having you focus on how do we and why do we put some thought into how we space out the X and the Y axis and what is the labels on those. Okay, so we picked one on this side. Let's go ahead and do one more and call it a night. So let's see, which one should we do? Let's see, question number 1 says, Joel has D dimes and Q quarters with a total of D dimes plus Q quarters with a total of $25.50. Write an equation that represents the total amount of dollars in D and Q that he has. How many dimes and quarters does he have? So we'd have to write this, and how many dimes, well, whatever D is plus whatever Q is the total number of coins he has. Now, I mean, we could say, it doesn't say, but we could say that he has 2 quarters, right? So if he had 2 quarters, that's 50 cents. That means everything else is in dimes. The rest is dimes. So that means he must have 250 dimes. So in total, he'd have 250 dimes plus 2 quarters. So that's a total of 252 coins. Now, they don't say actually solve it. They're just saying, how would you kind of put together an equation to, depict what's being described in the song? Or the problem. So I'm going to go ahead and do one more just because this was very different than the other problem. So let's go ahead and do one more and call it a night. Question 2, Sadie has a cousin, Nanette, in Germany. Both families recently bought a new car, and the 2 girls are comparing how fuel efficient the 2 cars are. Sadie tells Nanette that her family's car is getting 42 miles in 1 gallon. That's how far they go in 1 gallon. So that's what Sadie said. All right, Nanette has no idea how this compares to her family's car because in Germany, they measure them differently. She tells Sadie that her family's car uses 6 liters in 100 kilometers. So she knows that when she goes 100 kilometers, she uses 6 liters. So notice this is distance. And this is amount of gas, okay? So regardless of how they ask Nanette, if we're going to compare the two, we have to say that distance, we went 100 kilometers, and amount of gas, 6 liters. However we do it, we have to show it in the same way. Okay, so now we've done that. This is in distance, that is in liters. Now we have to convert this. So as I've told you, you do get a conversion factor on the test. You rarely need it, but in this question, I need it. Okay, so I'm going to go to the internet, but on the real test, you'll have a formula sheet. So I'm just going to go to Google. If you're sitting at home, right? And just say formula sheet for Algebra 1 Florida, EOC. Okay, so let's look at the formula sheet for the Algebra 1 EOC. Here's the reference sheet. Okay, yeah, here it is. Okay, so I need to know kilometers and liters. Kilometers and liters. Okay, here we are. There it is. Kilometers and liters. So I'm going to take a picture of that and drag it back to my problem here. All right, nice. Kilometers and meters. Okay, so I need this. But hold on, that doesn't help me. Let's start over. I need to know how many liters are in a gallon, right? And I need to know how many miles are in a kilometer. So, okay, back to the formula sheet. Too fast. How many meters in a kilometer? They don't give me the conversion. Yeah, you can't convert it if they don't give it to you. Gallon and a liter. They don't give it to me. Okay, so it would have to be provided in the problem. They should have told me. That's okay. Imagine that they should told you. So we'll go and we'll Google that. How many miles in a kilometer? Okay, so 1 kilometer is 0.62. 1 kilometer is 0.621 miles. So 1 kilometer is 0.62621 miles. Okay, so this is nice because kilometers will cancel, and now I do have miles, so now I can compare. Now let's Google how many liters in a gallon. Okay, so they would have to provide this, but we can Google this. How many liters in a gallon? All right, liters again. 1 gallon is 3.785 liters. 1 gallon is 3.785 liters. 1 gallon. All right. So, can I cancel this? Yeah, liters and liters cancel. So I get my answers in miles, per gallon, gallon. So I can compare Sadie and Nanette. I just need to get this in the same labels, which I have. So I have to multiply all the numerators. So 100 times 0.621 times 3.785. And then I need to divide by 6. Okay, so let's try all that. 100 times 0.621. Okay. Times 3.785 times 3.785, enter. Go back to my, and then I need to divide by 6, okay? So I'm going to divide by 6. Beautiful, 39.2. Let's just round, 39.2. Okay, so this is 39.2 miles in 1 gallon. Miles in 1 gallon. So who gets better gas mileage? It looks like it's Sadie. So I'm not going to work question number 3, so this gives me some room here. Question number 2, Sadie gets better gas mileage because 42 miles per gallon is greater than 39.2 miles per gallon. Love it. Thanks for joining us, guys. See you next time.